Hi, you guys. So we're going to get back into the next few questions. So this is going to be numbers 6 onward, right? And we're going to continue solving some of these problems. And again, a lot of these problems are really about understanding the vocab and being able to go ahead and to understand what they are asking you in each of these questions, right? So now it says that in guinea pigs, black fur, this is a typo, is dominant over white fur. Cross a heterozygous black guinea pigs, right? So heterozygous, right? So if we're talking about something being heterozygous, right, it has one dominant and one recessive. Dominant, one recessive, right? So that's what it means to be hetero. So one of both, right? And then it says that is dominant over white. So this means that it is complete dominance, right? So if you're completely dominant, it means that you're either black guinea pig or white guinea pig. So there's no gray guinea pigs, no spotted guinea pigs, none of that business, right? So I either have a list of my few, right? So for these guinea pigs, right, I have black, which is going to be BB. I have another black guinea pig, and then I would have my white guinea pig. So that would be my deal on there. So they're telling me to go ahead and to cross one dominant, one recessive, which is this guy, right? And I have two heterozygous guinea pigs that I'm crossing. So I get back in here and I write capital B, little b, because both of them are heterozygous. I go ahead and I cross these deals, right? Oops, that's a mistake. I did it again. Okay. And then I would have that for my thing. So it says, what are the percentages and possible genotypes and phenotypes, right? So going ahead and starting with genotypes. So again, genotypes, as we reviewed last video, is going to be the actual genes or the letters, right? So I can have capital B, little b, and little b, right? And then I'm going to write percentages for each. So in order to get my percentage, I have to remember that in my Punnett square, right, each of these are worth 25%. And 25%. So I go ahead and I add up what I have. So capital B, I have only 25, right? Capital B, I have 25 again, right? And little b, I have 25. Ooh, mistake. 50, my bad. Right, so I have 50 and 25. And again, I can double check these and see if these add up to 100. So 25 plus 25 is 50, plus another 50, that's 100%, right? Now I have to do my phenotypes. So my phenotypes are my looks, right? So remember that I said that I can only have black or white. So I go ahead and I look at my Punnett square right here. And as long as I have one capital B, so one dominant one, right, that means that that guinea pig is black. So I go ahead and I look over here and I have 1, 2, 3 black guinea pigs. And if I add 25 together 3 times, I get 75%, right? And I have only one white guinea pig, right? And this is 25%. And again, right, I can use the reference that I made right here to go ahead and kind of see that. So the capital B's are black. Capital B, little b is capital B, little b is black as well. Oh my goodness. So that is that one there. So now we're going to go ahead and we're going to move on. It says in peas, side flowers are dominant over end flowers. And in this case, right, they want us to cross a homozygous recessive plant with a heterozygous plant. So notice that it says dominant over, right? So this one is complete dominant. So it means that I either have side flowers or end flowers. So there is no in between. It's either side or end, right? So I'm going to go ahead and I'm going to do F's. And the reason why I'm going to do F's is because I don't want to do S's because S's, like, you can get confused really easily. Okay, so a capital F is going to mean that it is a side flower. And a lowercase f is going to mean that it is an end flower. And they are going to go ahead and cross a homozygous recessive with a heterozygous. So homozygous recessive, again, if you guys are looking at your cheat sheet you made in class, right, homozygous, homo means the same, right, recessive means that's going to be the lowercase letter. So homozygous recessive looks something like this, right, and a heterozygous plant, right, so heterozygous means two different ones, so I'm going to have a capital F and a little f. Right, so those are my things on there. So I'm going to go ahead and I'm going to cross these parents. So capital F with little f, and I'm going to go ahead and I'm going to complete my cross, and I get something that looks like this. And they ask us what are our percentages for our possible genotypes. So we have three possible genotypes. I have capital F, capital F, little f, and little f, little f. So now I'm going to go ahead and write my percentages of each. So I look on my Punnett square. I'm looking again at all of the possible offspring, right? And I don't have any capital F, so that's going to be 0. I have 2 capital F, little f's, which is going to be 50%, right? Because, and again, each box is worth 25. Right, and then I have little f, which is 50%, right? And now I'm going to go ahead, I'm going to work on phenotypes. So for our phenotypes, remember that we said that capital F is a side flower and little f is an end flower, okay? So those are our percentages. So I'm going to go ahead and write side flower and end flower. Oops, I dropped the R right there. Okay, so then I'm going to go ahead and I'm going to look at my Punnett square. If it has one capital F, that means it's a side flower. So if I look here, I have this one and this one, right? And then that will be a side flower, so that'll be 50%. And then I look over here and I have little f's, right? So if I have two little f's together, that means it's going to it has no choice but to show that end flower trait. So then that one will also be 50%. Okay. So now going into number 8, it says in some cats, the gene for tail length shows incomplete dominance. So if I'm going ahead and if I'm showing incomplete dominance, right, that means that I'm going to have a spectrum or I'm going to have blending of colors, right? So in this case, since it's a length, it's going to be a little bit more of a spectrum, right? And I'm going to see that in the next sentence. So I'm going to write spectrum / blending. Okay, it says some cats have long tails while others have short tails or no tails. So that is our spectrum, right? For each of the following, construct a Punnett square, give the genotypic and phenotypic ratios of the offspring. Okay, a long tail cat and a short tail cat. So those are the cats that we're blending. But before we start, we got to go ahead and we got to write out what our key is going to be for our tail length, right? So since it is incomplete dominance, we're going to show a spectrum, right? So in incomplete dominance, we're just using almost the same type of letters, right? And we got to determine what each of the letters mean. So we have long tails, so that is going to be this one right here. So this one's going to be our long. Our next one is going to be our short tails, and then our next one is going to be no tails. Okay, so that is pretty much our spectrum, and we're going to solve it in the next problem.